Hello, sixth grade. Um, I am still at home, obviously, and just wanted to make sure that I got something down for you today, lesson wise, and continue in our discussions about renewable energy and make sure that you know where all of our resources are and that we're keeping things up to date. So, I do actually, at first, I want to say thank you to all of you who have checked in on me to see if I'm okay. And I just want to reassure everyone, like I'm doing fine. We just have a minor case of daycareitis, I guess is a good way to put it. And it's just a matter of being very contagious, but nothing serious. So again, I appreciate everyone checking in so much. It means a lot to me. And I appreciate the hard work and the thoughtfulness that I'm seeing in answers from a lot of you. It does my heart and my noggin a lot of good to know that even if I'm not there, I have students who are responsible and motivated enough to take their learning seriously and do what they're supposed to do and do it with thought and engagement. So a little bit of student appreciation, if you will. So let's go ahead and hop right into it. I'm going to switch us over to presentation mode. I left my glasses at work, so I'm trying to make sure I hit the right button. There we go. Going to pin myself to the board. And again, I will apologize for the background sounds, which you're probably going to hear a few of. I do have my tiny co-host. He's thankfully taking a break right now and watching Spider-Man. So we're going to kind of try to get things done quickly. Okay, so my goal for today is to make sure that we get our notes caught up, our class notes, which remember are in Google Slide form, and go over those next couple of renewable energy topics with you to show you where I'm adding things on Google Classroom so you can go back and use that for review prior to test time on this and to kind of explain a little bit about where we'll be going over the next couple of weeks. So I will try to keep it short. Doesn't always work out, but we'll try. Okay, so let's see. Going to Miss Johnson's sixth grade science class, I will be during sixth period leaving my meet on and making sure that you can like check in and have hit me with any questions that you have. So on our renewable and non-renewable energy sources, we have our lessons. This is our lesson from the other day. I will add in this video to this section when we're done. I am going to edit and add in the first couple of pages from our textbook, pages 179 through 185. The first couple where I have annotated and done things there. So let me find my photos. Oh, there they are. All right. Okay. So I am going to hopefully get these in the right order. All right. I'm going to upload these images for you. All right, so now among your resources, you'll be able to go in and look at how I've done my textbook images. And I will actually go through and retitle those because that's a little bit confusing. But you can see, you can see that I have, the sun fuels the water cycle, the things that I have underlined, just some stuff kind of showing what I've done with mine. And hopefully that will help. Let's go ahead and just rename while we can. Okay, so I'll take care of that later. Anyway, so now those resources are there for you as well. So getting back to our class notes. Hopefully the slideshow format is working out well for you guys. I'm kind of linking out to these. Oh, sorry. So anyway, close that out. Uh, I have these so that they link to the video lessons. So section one, where it goes through our introduction, that lesson will link there. When we get to renewable energy sources, pros and cons, that actually links to something else. So I need to go through and put something in here to link us out to that video. Okay, so here I want to show you that I am putting in a link. You know what? I'll take care of that later too. I will put in a link to the day 2 lesson there. Sorry, I'm a little discombobulated. Okay, so hydroelectric energy. When we talk about hydroelectric energy, it's really important that we look at breaking it down into two words. One being hydro, which, it sounds like hydrogen. And if we think about it, dihydrogen monoxide is the chemical formula for water. If we think of hydrocephalus, that means like having water on the brain. If we think of, hydroponic growing methods for crops, we think of growing in water. So we know that hydro is Greek, I believe, and I'm sure Mr. Gilmore or Mr. Irwin could correct me if I'm wrong there, for water. And then electric, we know, comes from the movement of electrons, and we have hydroelectric energy. So energy from water. And what I have up here are pictures of dams. And there are lots of different kinds of dams, but I have these up here specifically. So this is, of course, the famous Hoover Dam, made famous by many things, which provides a lot of power in the American Southwest. This is a more modern, eco-friendly kind of dam. It still builds up a reservoir, but you can tell the generation is going on here while there's still an area here for fish to move through freely. And I like that design. It's not perfect, but it's a little bit better. And this is South Holston Dam, which many of you I'm sure have visited. It is not far from us at all. It's about a 15-minute drive from my house. I go out there to go running quite a bit. South Holston Lake we're pretty familiar with. So this is where most of the power that we use is generated. If you live closer to the Kingsport side of things, it may be Fort Patrick Henry. And then, of course, we have Boone Dam, which is kind of, I think, back in working order and produces a smaller amount of electricity as well. But we will take a look at just the Holston River alone and talk about how much it has an impact on the power in Tennessee. So when we look at this, hydroelectric energy is going to be produced by water, which is usually dammed up into a reservoir. It's going to flow through what are called turbines, and we're going to see turbines pop up again and again. We saw it in solar energy. It's going to play. It's going to play more Spider-Man. Don't you worry, son. More Spider-Man is on the way. Sorry. Anyway, so we're gonna see this water going through and spinning these turbines really fast, and as they spin, they generate electricity. So there's no air pollution associated with this exactly. However, there are some problems that we'll get into in a few. So let's watch this video real quick. All these little Department of Energy videos are really good for just showing you a quick breakdown on how things work and giving you like an image to go along with that. Okay. Okay, so that gave a lot of information in a really quick breakdown, and this is Charles. He's not feeling his best, so he wants to be in my lap, and I hope that's not too much of a distraction. Anyway, so some of the power, some of the suggestions that were being made. One of the, hey, you want your crayons? You want your crayons so you can draw?
Nope.
Anyway, the diversion dam that it showed that kind of lets the flow of water go around and things like fish ladders, which I thought that was a made up thing when I first heard about fish ladders. I was like, that's not real. Fish can't use ladders. They don't even have arms. And hold on just one second. I'm going to try to solve this problem. Hey. Look. What I got for you. Yay. Yep. Go get your paper. Okay. Sorry. It's a little complicated. Anyway. So yeah, I thought these were totally fake, and then I got to see one in action in Alaska, and it's really cool for fish that migrate and like have to go upstream. It helps them navigate basically around the dam and get to where they need to go. So the environmental impacts of dams are not inconsequential, but a lot of it depends on the kind of dam structure. All right, let's get back to our notes. Here we go. Okay, so whereas there's not explicitly any air pollution created from this, one of the problems is in these reservoirs, and especially if we look at really big, what are called mega dams, like the Three Gorges Dam in China, which is currently the biggest dam. I'm going to show you. Let's see. I'm going to show you on a map, like exactly how much water this dam holds back. It is estimated that within the stop it. Sorry, my computer's being a little sensitive today. Okay, So this is the the Yangtze River that's being held back. You guys are probably learning about that in Mr. McQueen's class. So we can see this is a pretty big river. It really flows through China along with the Yellow River. It's one of the major rivers there. It's one of the major rivers in the world. So the Three Gorges Dam has built up this enormous reservoir behind it. It in fact even says hilltop views of an enormous river dam. So, if we go in and look at this, I mean, the dam itself is literally the width of this city. Um, it holds back so much water that normally would be flowing. Now, water that is flowing keeps a lot of oxygen in it, and it's very healthy for the environment. And flowing water, flowing rivers, it's generally good for things. It's kind of like the idea of you want your this is a little bit crude, but you want your bladder to be flowing, right? You want things to flow, to get toxins out and everything. Same idea for the earth. This is sort of like how a lot of toxins get put out to sea and then kind of dealt with through some natural processes. When these rivers are dammed up, you have to keep in mind that here's what happens. An area like this width, right, and that is maybe not so deep, is now suddenly getting turned into this enormous reservoir or enormous lake. We see this even at like South Holston, that is extremely deep. And all the stuff that flows through and should just keep flowing builds up in here, and the water becomes stagnant. It stops moving. So when that happens, a lot of things like fish that require flowing water to survive, a lot of plants that require flowing water, and debris that collects in the river, it all just gets stuck in here and starts rotting. Rotting things release carbon. So one of the concerns with non-renewable or fossil fuels is the amount of carbon they put in the air. But this dam's reservoir alone in 1 year managed to emit the same amount of carbon emissions, about 20% equal to the emissions from automobiles in the United States. So that's an enormous amount of carbon. And we have several of these mega dams all over the world. And even smaller dams like ours actually do that. Now, if we take a look here, we can kind of go in a little closer and look at the actual dam. You can see this is just a massive, massive structure. Now, one of the kind of dumb things about this is this area of China in particular. It's this dam is built directly on a fault line, or very close to a fault line. So there is a tectonic plate that runs kind of through here, not far off, and this area is prone to earthquakes. So is it the smartest place to put a dam? Absolutely not. It is suspected because we have such large population centers down the way. If this dam were to break within, just because of the population density, within a couple of hours, a number of people equal to the population of the United States would be, in fact, rather dead. So that's not great. Okay. So another thing, along with the carbon, like I said, they stop the flowing of water, and this destroys a lot of aquatic ecosystems. Tennessee lost about 70% of its species of fish when TVA came in and put the number of dams in that they did. Now, on the other hand, we got a lot of good out of that too. The Tennessee Valley has better flood control, and that used to be an enormous problem for people. We have a clean source of energy, a mostly clean source of energy. You know, again, we still have some, this should be a flowing river, but instead is now a lake. Tennessee only has one natural lake, and that is Reelfoot Lake in Northwest Tennessee. So this water, you know, it loses oxygen, it does emit carbon, things like that, but it's for the most part clean energy. So it's done a lot of good, but it has destroyed a lot of habitats. This again used to be a river habitat, and with a lot of forest around it, it's been crushed, and that has been the case in a lot of places. So smaller dams often cause less damage. They have fewer problems associated with them, but they're also a lot of times not used for power. I think they said 3,000 dams are used for power, and we have 80,000 in the US. So if we could start generating on smaller scales, that would be really, really helpful in making this work. So that should say to us, hydroelectric energy is extremely important to us. The Tennessee Valley Authority is the reason we have power here. It is the reason that Appalachia was able to kind of develop out of a depressive slump it was in the 1930s. It's the reason that we have some of the lowest electricity costs in the country. We have an abundance of rivers, just tons and tons of rivers. We are lousy with rivers around here, and we utilize those water sources well. So continuing on, I told you about the Three Gorges Dam and the problem there, but people are becoming more environmentally conscious. So the things that are coming in place to kind of help make dams a little bit more efficient are, you know, things like this, where we see this is a diversion. We see part of the river being used to generate electricity, and it's using the natural flow of the river versus creating a reservoir. So the river just keeps on flowing as it does. And, you know, we have places here where it's totally uninterrupted. And that's very good for the aquatic habitats. And, you know, helps them sustain things. Now, this will not produce the same amount of energy that a mega dam will, but if we put in more of these and utilize more of our smaller dams in this way, we could really reduce a lot of the environmental impact while increasing our overall power creation. This again is a fish ladder. It is a real thing. The way it works is, you know, fish who need to get upstream are able to swim here, hop over, swim here, hop over, swim here, hop over, swim here, and they get up and around. Like I said, I got to see one of those in action in Alaska, and it actually turned into a really, really horrifying story. I will try to find my pictures of the one that I saw in Alaska, and it was very cool. And a lot of places, even near mega dams, this is actually just a little west of the South Holston Dam as the river flows out, create weir dams. And weir dams used to be used for kind of trapping fish, but now they are being put in place. I realize if I'm going to use hand signals, I need to go back to where you can see me. So they're being put in place where we have gravitational potential energy in the reservoir built up in the water, and then it goes through the dam, flows down, flows through the river. And as it goes through the river, it goes over this weird dam, and the water is all churn. And as it does that, it re-oxygenates, which apparently is not a word, but I think it should be. I think it's just oxygenates normally. But I feel like since the oxygen was taken out, we're putting it in again. There should be a re there. Either way, it adds oxygen to the water and then sends it on down for a healthier river. So, you know, one of the examples like this hydroelectric is always interesting to me because I live on a river. So I live on the Holston River, and when Boone Dam was broken and down, it was the case that we had just the flowing river through. We had like an eagle move in, and you know, the ecosystem changed dramatically. Plants started popping up around it, and I got to watch this ecosystem change from what used to be kind of like, we're right where it turns into Boone Lake, kind of used to be a lake, turn back into a river, and I got to watch that process happen. And now I'm seeing it go the other way, and I'm starting to see species disappear, like my number of fishing birds, herons and kingfishers, the eagles. They're gone now. They've moved somewhere where the water is still flowing. And like bummer, but also good because Boone Dam will now be able to continue creating power. So there's a lot of complexity with hydroelectric, but I think it is probably our most promising source of renewable energy that we have going right now. And it's already close to making 10% of our power. It could go a little bit further. Yeah, actually, I think it could go a lot a bit further. If we started really utilizing the dams that we have in place, we could go a lot further with this. Um, so I feel like I've talked for a really long time, and I don't want these lessons to be too long. So I am going to go ahead and show you a link that I would like for you to watch. You don't have to watch it, but it is really like worth your time. And then after I show you a couple of minutes of this, I'm gonna cut this lesson and then start a new one for our remaining energy. I want these to be palatable. So this is a historic film that shows. I'll give you a big hug. You can get a big hug. Nope, nope, those aren't for you. Nope. And also, I have a feeling it's close to nap time. So I'm gonna go ahead and just let this play, and you guys are welcome to watch it. I'm gonna go try to get nap time started. Hopefully it works. But this just shows kind of the TVA, and at least watch the first maybe 15 minutes of it. If you watch the whole thing, great. If you don't, that's fine. But give it a few, because this is your history. This is like the history of our area. This is the history of like how we got to emerge from being kind of the laughing stock of the country to being a productive and valuable part of society. So I don't know. Enjoy, and I will see you guys later.